Howdy, everyone. Hopefully you can hear me now. Bonus points if you couldn't hear me before when I had the splash screen up. Uh, hey, Andrew. Welcome, welcome. I'm more zoomed in today. Yeah, I did that, and then I was like, maybe I want to be a little less zoomed in, and then the OBS was like, no, I don't want you to be more zoomed in, so we're going to live with this. If I'm too zoomed, I will maybe do it during a break or something. Okay, and now YouTube is going to uh, make my life difficult by not popping out the chat when I ask it to pop out the chat. There we go. Okay. Um, well, it wouldn't let me unzoom it out, so you're gonna live with it. Okay. And now we try and remember what the command is to make the window always on top. There we go. Alrighty. Uh, Tristan is complaining. It must be bad. He doesn't like looking at me this close up. That's probably it. Let's see. If you really want, I will see if I can adjust it. Let's see if that is an option. Will you? Nope, it just doesn't do anything when I hit configure video anymore. Let's see. I can turn off the camera for a second, then configure the video. Well, now that's even more interesting. One moment. Interestingly, deactivating the camera did not make the camera go away. OBS being very stubborn today, apparently. Well, I think we're going to live with it. That is my official choice for now. I can try and futz with it more later. The audio stream is low. Can you really not hear me? YouTube claims I'm not making audio. But I think I should. Okay. Whatever. YouTube is crazy. OBS is crazy. You could argue the common denominator is me, but I'm not going to think about it. Okay, so long story short, it's about to be finals week, and I was doing my very best to procrastinate doing or writing finals. And in so doing, I just flipped through 60 pages of LMD picking out puzzles that I wanted to do. And then there were enough puzzles I wanted to do that I was like, I'll just do a stream of puzzles so that I can get a little bit caught up with some of my puzzles I want to do. So this one I'll start with. But then we'll see where we go. I have some others queued up. Hopefully the screen setup, aside from me being too zoomed in, is right. Looks fine to me. There we go. I'm slightly... No, that made me less centered. Okay, there we go. Doo-doo-doo. So, let's see. We've got this puzzle by Playmaker, which is an arrow killer Sudoku with no additional rules, right? No additional rules. So digits in this cage sum to 25 and don't repeat, so that digit and that digit are not the same. Digits in this cage sum to an unknown total and don't repeat. And the digits along the arrows sum to the digit in the circle. And so in particular, that means that this digit sums to this digit, so these two digits are the same. That's all that's saying. Okay. Oh, they do sum to 45. Sorry, I counted this and got that it had 7 cells in it. I don't know how many times. But in fact, yes, it does sum to 45 if you have subscribed to the Tier 3 on Patreon for Cracking the Cryptic, where you're allowed to use Simon's Secret. All right, so speaking of Simony things, my keypad doesn't work if I don't turn it on. Speaking of Simony things, let's start with the fact that these are length 3 arrows that sum to some total that has to be at least 6. And that's because the minimum I could put on this is 1, 2, 3. It's pretty easy to accidentally mess this up if you have an arrow that crosses boxes where actually you could repeat a digit on it. But fortunately, we don't have to worry about this time. Okay, so one thing I am seeing is that... Wait, no, never mind. I was going to claim this digit has to be a 1, but I don't believe me. I know there has to be a 1 somewhere along these. That I believe. If you want to know the secret that Simon's talking about, you have to be a $5 a month or more patron on Cracking the Cryptic, is my understanding of how it works. Okay, so here we go. We've got a 1 somewhere in here, because if there wasn't, these would sum to way too many. The maximum these can possibly sum to is... And so here's my first observation. These two circles are different. And these two circles are different because if they were both the same, they would rule themselves out of this cage, which, because after chat counts the number of cells in it for me, it has 2 more, it has all the digits in it. And so these have to be different. So the max they sum to is 17. And so that means that these cells in total must have a 1, 2, and a 3 in them. But we could make 17 as 1, 2, 3, 5, 6, or as 1, 2, 3, 4, 7, and so we don't actually know we don't know the other digits. Okay. Now, as Tallcat points out, this cell can't possibly be as big as 3, because if it's as big as 3, what happens? Then the total must be... Tallcat's pointing out that I'm full of shit. Let's see. Let's try again. Oh, yeah. So it is true to say that these sum to at most 17. But the thing I'm not counting, off to a great start already, is that this cell is double counted. So actually, the total of these two, which again are different, but the total of these two is not the sum of these 5 cells. It's the sum of these 5 cells plus this cell a second time. So this is an extra special cell that gets counted double. So these total at least 10, and I can't exceed 17 when I add double this cell. So this cell certainly isn't more... Oops. This cell certainly isn't more than 3. Although Tallcat claims it can't actually be 3. Let's double check. Yeah, so the minimum these can sum to is... the minimum these can sum to is if these are 1, 2, 3, 4. Oh, those can't be 1, 2, 3, 4 because... Yes, okay. So... Here's the right way to think about this, not the way I was thinking about it. These 5 cells sum to a minimum of 15, plus the purple cell can be at most 17. So the purple cell can't be as big as 3 because that would make it minimum 18. Okay. But the minimum, the total of all of these plus the purple cell sums to is 16 if they're exactly 1, 2, 3, 4, 5. And this digit is a 1. And so these circles cannot be 6. And one of them is definitely a 9. Because if they were 7, 8, they would only sum to 15. And I'm not even touching the desk. I guess the camera is too zoomed in, but I don't think I can fix it. I can turn the camera off if you want, but that is the best I can do. Because it is for whatever reason not letting me do anything when I hit the configure video button. So that's that for now. I'll have to restart OBS in order to fix it probably. So that's not a 9. is one of the morals of the story. Because one of these two is a 9, and they both see this. And these also now have to have a 4 in them, right? Because now, again, we're summing these plus this again. And so we need these to sum to, at most, 16, right? And so these also have a 4. And that one's not the 4. Okay. These two cells are the same. I could have noted right away, but I'll go ahead and mark that because it feels like I'm doing something. Hey, Joe. Let's see. Yellow. Then in this box, I guess yellow could technically go on this arrow. I don't see any reason it can't. There's definitely a 1 on this arrow. I don't know if that's going to do me any good, but I'm going to note it because it makes me feel productive. Oh boy, is this going to be a set puzzle? Oh lord. Boy, I hope not. Let's see. Someone is suggesting row 7 and column 3. And then looking at stuff about parity, which makes a lot of sense. So I think the parity argument here is something like this sums to an even total. This sums to an even total. So I know that this in total is an odd total, and this in total is an odd total. So that means that if I exclude this, these have the same parity. So this vertical strip has the same parity as this horizontal strip. Which is, I think, what people are suggesting in chat. And if these have the same parity, I think the punchline is this has to be a 7-9 pair. That's my guess as to where this is going. But I'm not yet seeing it completely. The digits on the arrow have to appear in the plus sign. Do we mean these digits? Ah, those digits. Gotcha. Those have to contain 6 different digits. That's the point. Okay. So this is the refinement, thanks, Rinsk, of our previous observation that these two couldn't be the same, because if they were the same, it would rule that value completely out of the plus sign. No digit on any of these can be the same. In fact, actually, between all 8 of those digits, there can be no repeats. And so, in fact, there's actually this weird extra region in this puzzle consisting of all of these cells. Because I'm not allowed to repeat any digits anywhere in here. Okay, so what do we do with this extra region thingy? So these 4 digits are these 4 digits. Let's see. Okay, parity again. People keep saying parity, so I want to think about parity. Okay, this row, this row sums to 45, plus this column sums to 45. That's 90, but I've double counted this cell, so the total of all of these things is 90 minus... It is 90 minus this cell. I still don't think that helps. So the total of yellow... So here's one thing that's useful. we know arrows sum to an even total. So if we're talking about the fact that the yellow region sums to 45, it sums to an odd total, so I could just drop those. So I guess the conclusion is these three numbers sum to an odd total. Right. I think that's what people have been trying to get me to get to. Is that really super helpful? Yeah, so the three of them sum to an odd total, and they have a 9. So... Oh, and they come from 6, 7, 8, 9. I guess that's the point. So they come from 6, 7, 8, 9. So what are they? They could be 3 odds, or they could be an odd and 2 evens. Except if you carefully count and have chat double check, you'll find there aren't 3 odds in 6, 7, 8, 9. And so the punchline of this is there's no 8 in those. Oops. And so these are a 7, 9 pair, and that's a 6. All right, so this is a 1, 2, 3 triple. Wait, no, I added wrong? Oh, no. One moment. Let's do parity again. Okay, so these three have to add to an odd total, which means there needs to be 2 evens and 1 odd. So we actually rule out 7, not out... actually rule out 7, so it actually looks like that. So now 8 plus 9 plus 6 is 23, which is legitimately odd. Okay, so that is a 6. This is a 1, 2, 3. But now it looks better in terms of parity, I think. I am going to go ahead and put these back so that I can remember this region. Look, I never claimed I was a good number theorist. All right, so there has to be a 1 on one of these arrows, and a 2 on one of these arrows, and a 7. Let's see, 7's got to be the hardest, right? 7 has to go in the bulb of one of these arrows. And I'm just going to pencil mark this like that. Because I can't put a 7 on an arrow when everything bigger than 7 is gone. And that 7 can't go with the 1. So the other arrow, the one that doesn't have a 7 on it, has to have a 1 on it. So the 7 arrow is either going to be a 2, 5 or a 3, 4. Do I know which one? I'm guessing chat knows which one. I am glad that I picked a puzzle where chat has all done the puzzle. To answer your question, I am nominally an arithmetic geometer. That's what my research is in. But my YouTube channel about math is about analytic number theory and the zeta function, which is why I set puzzles under the name. Okay, there's a claim. Oh, welcome, Jessica. Congratulations on your CTC feature. Okay, so the claim is, and this is super weird to me, the claim is, okay, I can't use 3, 4, because if I use 3, 4, 7, then what are the 3 numbers that are left over? The 3 numbers that are left over are 1, 2, and 5. And I can't make 1, 2, and 5 work out to be a sum. Okay, I agree. I buy that. So one of these arrows is 7, 2, 5, and the other is 3, 4, 1. Okay, so this is either like this, or the other way around. Okay, so let me try and pencil mark that in a way that is maybe more useful. These are a 4, 7 pair, and these are either 2, 5 or 1, 3. Okay. What is your favorite area of math? Okay, let's see. Does this do anything interesting? So if this were a 725, does that break? Oh, if this was a 725, does that break this 8 cage? It does break this 8 cage. Because the only ways to make 8 are 1 plus 7, 2 plus 6, and 3 plus 5. So the 8 cage can't go with the 725. So this is a 413 arrow. And this is the 725 arrow. Okay, people are telling me there's a 6 that I can place in box 5. There is very a 6 I can place in box 5. I agree. And there's also one of these that I had not really appreciated. Algebraic number theory is very cool. I was just actually talking about unique factorization domains in my algebra class. So this green digit gets pushed here, and so as a result, it must be from here. So it's 1, 3, or 4. Okay, no one wanted me to talk about the green digit, but I talked about it anyway. So people want me to talk about 7, 8, 9 in box 5, which is an excellent point, because now we know these things actually really are 1, 2, 3, 4, 5, because 6 was the other thing that could go on this, because remember, these 5 cells, if you didn't double count the 4, were forced to sum either to 15 or to 16. And, well, the only way they could have summed to 16 is if they were 1, 2, 3, 4, 6, but now we've placed a 6 here, so they're not 1, 2, 3, 4, 6, they're 1, 2, 3, 4, 5. So we should good lift that. And so these are 7, 8, 9, with a 5 sneaking in for good measure. Green could also be 8, 9. Oh no, oh no. Well, there were some complaints about good lifting, so I feel like it's revenge for whoever was complaining about good lifting to now have green pencil marked with 1, 3, 4, 8, 9. Okay. Oh yeah, so as pointed out by Niverio, beautifully, now I know what the repeated digit has to be, because as I just argued, these 5 cells without repeating sum to 15, and with good lifting, and with repeating, they sum to 17, because I know these are 8, 9. So these are a 2. So this is a 2. Okay, so one of these arrows does not have a 1 on it. And so one of these is a 2, 3, 4, 9 arrow. And the other is an 8 arrow that has the other stuff on it. 2, 1, 5. I don't think I know which it is yet, but I want to look at this 12 cage, because the 12 cage can't have a 7 in it. Oh, actually, let me look at the 8 cage, because the 8 cage can't have a 1 or a 3 in it. So this 8 cage is a 2, 6. It has no other options, because it can't be 1, 7, can't be 3, 5. So these aren't a 2, so this is a 2. So that's a gimme. So let's see. So there's got to be a 6. Actually, there's got to be a 6 on this arrow, just by good old Sudoku. Tidy mind. I don't even I don't know that I would go that far. So let's see. So this has got to be a 7, 8, 9 itself, which gives us a 7, 8, 9 triple in the column, which is assuredly going to be interesting. Oh, and it can't be 8 either, because in order to be 8, it would have to be 6 and 2, but there's already a 2 going in the row. So the 8 in this column is here. So that's not an 8. So yeah, so this is 6 and either 1 or 3. I don't know which yet. And interestingly, because of Sudoku, the other 1, 3 is here. Because 1 and 3 are both forced into this row by Sudoku. So let's see. So what's left here is 5, 7, 8, 9. I don't know if that was useful to pencil mark, but it might bother Tallcat, so I'll go with it. So this isn't 5, 7, so this is either 4, 8 or 3, 9. So there is an 8 or a 9 on here, which is notable. But I don't know if that is an 8 or 9. I don't know if that 8 or 9 is the 8 or 9 that ends up in there, is what I meant to say. Okay. There's definitely a 4 somewhere in this column, but that doesn't seem super useful. So there's a 2 in one of these two cells. I know that much. Just because of the aligning 2s here. The 5s? I don't know anything about the 5s. Oh, Virtual has a point. Column 3 has 1, 3 pencil marked in box 4. Column 3 has 1, 3 pencil marked in box 4. Yes. Okay, so good point. Where do 1 and 3 go in column 3? 1, 3 are a hidden pair in column 3. That is an excellent catch, Virtual. So this is a 1, 3 hidden pair in the column, which means that green isn't 1 or 3. Green is 4, 8, or 9. So we have a 4, 8, 9 virtual triple in the column. No, that's not true. Forget I said that. Something kind of like that, but not quite, I think. Okay, so what else is missing in this column? So we're missing an 8 or 9, and we're missing a 4. And that's it. So this is a 4, 8, 9, where there's definitely a 4. Let's see. I might as well go ahead and pencil mark this, since my not pencil marking before caused me to miss that. So 2, 3, 4, 5, 6, 7, 8, 9. These aren't 2. Oh. Four in box 8, I am hearing. Yeah, 4. Where does it go in box 8? It has to go in one of these two places. I don't think I know which one yet. I am hearing green can also be 6. My original efforts... See, if people had just never said anything, I would have just known green was 1 or 3, and then the puzzle would be broken now. And then... I don't know, and then what? Okay, so green ends up down here. Oh, but green could be 6 as well. Okay, so this is the point. Green could be 6. So that's that. So where does green go in column 3? Sorry, no, I misread that. Where does 4 go in column 3? Tristan asks. There. Oh, ha 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 ha. Beautiful. Okay, so that 4 pencil mark removes that 4. Beautiful. Good catch, Tristan. And I think other people were really trying to get me to see it too. I just didn't get it. So I'm going to color my 8 9s now because I don't think I need this yellow anymore. And I want to keep track of the fact that this 8 9 is that 8 9. So we're going to make those red. Okay. I don't know that that really helped me, but I assume I'm going to have to keep track of this to eventually unravel this mystery of what's going on here. Okay, I've heard about 1 in box 7. 1 in box 7 is in one of these two places. Do I know which one it's in? 1 in box 1, pointing. Ah, yep, okay. Good point. Yeah, good catch, Virtual. That's the second, like, hidden thingy you've caught. Where does 1 go in this box? Well, I have no idea, but I know it's in this column. So that makes that a 3 and that a 1, which is progress. So this has got to be the last 5, 7, 8, 9 in the box. Let's see. Which puts a 3 in the 12 cage. Oh, so it does. Excellent. Okay, so, oops. So that is great. The 3 here with that 3 pushes 3 up here, because remember, this couldn't be 3. This is a really beautifully constructed puzzle, which I knew it would be because it's by Playmaker, but as always, very nice. So that 3 9 sees down here, so those aren't 9 anymore. Okay. Where are we now? Okay, so what's left in this box is 1. We've got a 2, we've got a 3, we need a 4, we've got a 5, we need a 6, we have a 7, we need an 8 and a 9. Oh, we don't need a 9. We already have a 9. So this is 1, 4, 6, 8 is what is left here. So that gives us a 1, 4, 6, 8 triple. So that's not an 8. I was hoping something saw both of these circles, or both of things I knew were this, but I don't think I have that yet. I don't think I'm quite so lucky. Okay, so this 7 or 9 is that 7 or 9. I can pencil mark that, and I know it's definitely not red. Again, I don't know if it's helpful, but I'm going to do it. But 7... so if it was 7, it would be over here. But I don't know that it's 7. Let's see, nothing's been pushed onto this arrow yet. Why is 9 corner marked in box 4? Because one of these two is a 9. I don't really need that anymore. Don't forget your 7, 8, 9 triple in column 5. Oh, thank you. Yes, we did talk about a 7, 8, 9 triple in column 5 much earlier. And now that actually is useful, because this thing can't be 7, 8, or 9 anymore. So that is only 2 or 5. And these are not 7, 8, or 9 either. I don't super want to go into pencil marking that just yet. Okay, so this 2 or 5. See, I'm looking at places to count 7, 8, 9s and see if I can make any clever arguments about that. Because there have to be 2 more 7, 8, 9s in these 3 cells. But I don't think that that is incredibly interesting. Okay, Kyle, I'll pencil mark this. I was resistant to pencil marking this because I was afraid I was just going to do that. But I actually see now why you think that that's nice, because that tells me the 25 cage actually has relatively small digits in it. Those are at most 11. So these two need to total at least 14. And to be involved in a 14 total, you need to be at least 5. So these are from 5, 6, 7, 8, 9. I might be able to do that math better later if I really want to. And there can't be a 7 in these, which is a good point. So 9 and 8 would be 17, plus 5 and 6 would be 28. So that's only 3 over what this could be. Oh, chat is telling me there's actually only 2 options for this cage, which I never would have figured out. But without a 7, I'm hearing... let's see. I'm hearing it either has a 2 or a 3, but it never has a 1, is what I'm hearing. So let's see. Do I believe that? 9, 8, 6 is 14 plus 9 is 23. Yeah, so this can't possibly have a 1. Okay, and if it had both a 2 and a 3, that would definitely be a problem. Because then these would total to 5, and I would need these to be a double 10 in order to make the 20. So, but if I tried not putting a 2 or a 3, that is, if I tried to put 0 2s and 3s in this cage, then this would be min 4, 5, 6, which is 15, plus 8, which is 23? Wait, that's fine, isn't it? I think I'm going to go with the plan of believing what chat tells me is true about these cages, and not try and reprove formulas for 25 cages. But the surprising thing to me about Tallcat's statement is it's impossible for this cage to have a 4 in it, which is really interesting and unexpected. Is there a super easy way to see that this cage can't possibly have a 4 in it? I don't think I see it, but... so if I take out 4, then I get 9, 8, 6... Let's see, 9, 8, 6 is already 23. Wait. Take out 4 and it's 21. Okay, gotcha. That's a good way. Okay, so if I remove the 4, then I need to make 21 and 3, and 21 and 3 is a little bit easier. There's only 2 combinations, which both involve a 7. Okay, perfect. Chat wants to know if it's possible that there's neither a 9 nor an 8 in here, which seems incredibly unlikely, because if there's neither a 9 nor an 8, this would have to be exactly 5, 6, and then these would be at most 3, 4. So yeah, there's got to be an 8 and there's got to be an 8 or a 9. Okay, so anyway, the upshot of all of that is I get to take a 4 out of that. Oh, chat thinks there has to be both an 8 and a 9. Oh, well, that would be good. Let's see. So if I just tried to not have a 9, well, let's just go back to Tallcat's list. Tallcat's list both have an 8 and a 9. So that means this is an 8-9 pair, going back to the Tallcat axiom. So that's a 3 and that's a 9. So that's not a 3. So because that's not a 3, looking at Tallcat's list, let's see, because that's not a 3, that's not a 5, owing to this this list. Okay. So this is the other 8-9. It's not that 8-9. So that's red. And this 8-9, I'm going to decolor the blues. I was really optimistic about coloring these blues, but it did not go anywhere. So I'm going to make those blue, because now I can actually do a little bit more chasing of these things around the grid, perhaps. I also am sort of in awe of these people having all the ways you can make 25 in 4 without a 7 just known off the top of their head, Cable B. But there are people who are very good at killer Sudoku. And then there are people like me who are not very good at killer Sudoku, as I have done a good job of proving. So, not 8, 9, yeah, not blue there. So blue here has to be in one of these two cells, which seems noteworthy. One of those two is blue. So one of these two is blue. Again, I was more optimistic than I should have been that that was going to be useful. I'm just going to back up and not do that for the time being. Because I know there's a blue somewhere in this row. Okay, so someone poses, okay, what happens if blue is 9? Then this is 2, 3, 4. I don't see a problem with this being 2, 3, 4. This is 1, 5. Seems fine. Can also color with gray to signify color pencil marks too. Yeah, I like coloring with gray. The flash with gray is excellent for one of these is red. I use that a lot. I just try not to get too cluttered if I don't see it leading somewhere. Why did I color blue in box 8? It didn't seem forced. Oh, I see. So none of these could be blue. Oh, this could be blue. That was what I didn't do. Okay, yeah. So good point. There must be a blue 8, 9 in the 10 cage. Okay, so a 10 cage. This one isn't 4, 6. I want to verify that. Oh, yeah. Wow. Wow. That is an excellent point that it would have taken me a very long time to see. Okay, so there's 4 ways to make 10. One of them is with 4, 6, but it can't be that. One of them is with 3, 7, but it can't be that. The other two both involve an 8 or a 9. Well, that cell can't be an 8 or a 9, so this cell has to be an 8 or a 9, and it has to be blue. That is an excellent catch, Tallcat. I would have taken a very, very long time to see that. We'll be generous and say a very, very long time. Okay, so there is a blue 8, 9 in one of these two cells. Let's see. Also, it has to be an 8. I am hearing. Because blue now has to go in one of these two cells. Oh, or because that's just a 9. Okay, so this 9 sees it. So blue is 8. Excellent. Red is 9. Okay, and so we can lose our blue-red coloring, I think. And then we can clean up the central box. And now blue can't be green. Oh. I don't know why I left that one colored. Okay, and so now this is... Let's just clean all that up. That too. This is 3, 4. And this is 1, 5. Okay, so that's not a 4. And remember, we pencil marked 4 into one of 2 spots in this box earlier, so now that's a 4. Now the 4, which remember, for whatever reason, can't go in a 4-cell 12 cage with a can't go in a 4-cell 25 cage with without a 7 due to the Tallcat axiom. 4 is placed there. And so 4 now is not green, so green is 6. So all the people earlier who were saying, couldn't green be 6, good thing you did that. Or this would have been a very bad showing. So these are 5, 7, 9 to finish the column, I believe. I don't immediately see a way I can rule those things out. I hear there's a 1, 4, 8 quad in 1, 4, 6, 8 quad. Oh yeah, We used the 1468 quad in column 2 earlier for something. I don't remember what. Virtual 2-5 pair in column 5, I hear. These two things need to sum to 8. And so they're either 2-6 or 3-5. So there's definitely a 2 or 5 here. Pairs up with that 2 or 5, which tells us this is not a 5. So that's a 1. That's a 5. Good catch. Good catch, Kyle. So that seems like it should have done more than it did, but we'll go with it. Oh, so that's not a 1. I at least know that. Oh, there's a 9 in this box now, which is, I think, what Casey was pointing out. Yes, Casey was pointing that out. So that's a 7. Thank you, Casey. And so now this can't be a 3, so it's a 6, that's a 1, and that's a 3. This is a very technical puzzle. So these are not 7. That's a 7. That's not a 7. Oh, I'll try and remember to call you afraid not when you say something. Now 3 only goes in one place in the column. I'm not crazy, right? Yeah, 3 only goes in one place in the column now. It only goes there. So that's a 3, that's a 5, that's a 2. I do remember to call you Niverio, at least most of the time. That's not a 7, it's not a 9. Okay, so this is a 5-8 pair, but that one's a 5, that one's an 8. So that's not an 8, that's not a 9. That's a 5-7 pair, gives us an 8 there. One day the 8 in box 1 will be noticed. Maybe. Just wait, little fella. We'll get to you. Don't worry. Let's see. These are 8. Because that's a 5-7-9 triple. So that's an 8. Let's see. Have we done all the 8s now? Not quite. Oh, but there's an 8 on this arrow, which is huge. So this is 1 8, and that's a 9. So now what about 9s? So now there has to be a 9 down here. So those aren't 9s. Okay. And I have just noticed, completely of my own volition, and without any help from chat, that neither of these can be an 8, so that's an 8. Alrighty. The arrow +1 puzzle was really cool. I forget whose puzzle it was, but it was very cool. Oh, that's right, it was Ishut's. But you said exactly the same thing I did, which is that they have IPA pronunciation in their name, but I don't know IPA, so I just end up mispronouncing their name anyway, even though they did everything they possibly could to get me to say it correctly. Let's see. Thank you, Eleventicles. I was impressed with myself on that one as well. Oh, how on earth long has this been here? I don't think I really want to know. But anyway, the number that you add to 8 to get 10 is usually 2 in most spaces, where most is weighted by a measure based on how often those bases are used by human beings. In row 1, we still need a 1 and a 4. 2, 3, 4, 5. We need a 6. We don't need a 7, 8, 9. But this one's not 4 or 6, so it is a 1. So that's a 4, that's a 1. That's a 6. Oh, this 1-8 pair is looking at this 3-1. This puzzle is just so smooth. How long until someone tells me I'm solving a puzzle that Simon has solved on the channel? Is this a puzzle that Simon has solved on the channel and I just don't remember it? 5, 6, 7. There we go. 3, 4, 7. 4. Not one of those things. Let's see. That can't be a 3. thought that was going to pop up immediately, but it did not. Let's see. So these digits, 2, 3, 4, 5, 6, 7, 8, 9 there. So, oh, I don't know why I marked the box and then decided that I was only going to do the column. So that's a 2, that's a 9, that's a 5, that's a 2. 2, 3, 4, 5, let's see, 6, 7. 7, 6. 1, 2, 3, and so we need a 4, 6, 7 over there. Oh yes, I was very excited because I've recommended lots of puzzles to the channel before, and I have a long streak of recommending puzzles to the channel which don't show up on the channel. Which, I mean, there's tons of good Sudoku, so I'm not like upset that they haven't featured any of them. I have just always worried slightly when I submit I think this is a really good puzzle to the channel that I might accidentally be cursing them. But now that curse has been broken. But I am preparing my favorite 10 puzzles I've solved this year video, and the puzzle that Simon does today is one of the puzzles that will appear in that video. 1 goes over here, 3 goes there, 4 goes there, 7, 3. Let's see, 1, 2, 3, 4. We need a 5 and a 7. Need a 2. Looks to me like 2 is the only digit missing from this column, which would be an impressive discovery since I hear there's 9 digits in a column and there's only 7 marked, which would suggest there should be a second one. But I've checked more than once now, and it keeps being the case. 6. There's a 6 missing in the column. I don't know where it was before. This 7's looking down here at that 5 and that 7. So that's not a 7. So this box, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is 2 and a 4. Alrighty, so what on earth is going to break up this gigantic mess? This 7 is looking over here at this 5, 7. Okay, assuredly one of those has to do something. I believe. Maybe not. Oh, this 6 is doing it. So that's a 2, 6. That's a 4, 2. That 4 sees that's a 3, 4. That 3 is a 1, 3. That... I am very, very envious of Mark's ability to just look at any set of digits and instantly know what digit is missing from them. Great puzzle that I'm very happy to have had chat's help with, because I think there were many steps in that puzzle that would have taken me far longer. I think this puzzle would have taken me 4 hours if I had done it without chat to say, hey, look at how the 25 cage can't have a 4 in it. As though that was a thing that I would know. Let's see. I'm going to put up the... It is a Primesweeper. It is a Primesweeper vault puzzle by grkles. Excellent, excellent. I'm glad that the thing works. Playmaker often shows up for these streams, but didn't in this instance, which is fine. They can go back and watch the VOD. Okay, so This puzzle, I think, is likely to be one of the harder puzzles we've done on the stream, but I looked at it and it looked so cool and people were saying good things about it, so I was like, yep, I want to do it. So we're going to do it, even though I think this is likely to... There is a distinct possibility this will be the last puzzle we do today, but we'll see. All right, so what are the rules? Square digits contain the number of primes in the cells around them. So, in particular, this 8 is telling us that in these 8 cells, there are 8 primes. So, these are 2, 3, 5, 7. Oh no, now we have Niverio throwing down the gauntlet and saying it's not that hard. We will see. By grkles standards, yes, that sounds good. Now, the important thing to note... Actually, there's 2 important things to note about Primesweeper cells. One is all Primesweeper clues are given. So if this cell is not squared, then there are not, however many this is, primes in the square around it, which I presume is going to be a complete absolute nightmare to scan for. But what are you going to do? Also, the square counts itself, which also seems like a complete nightmare. So anyway, let's get started. And I'm shocked by this, but I actually see a digit I can place right away, which is that this has to be a 1, because it can't be a 0, and there is only... Oh, crap. It doesn't have to be a 1, does it? Because... Wait. Because it could count that one. Oh, no. So it's a 1 or a 2. Well, I got excited. But it doesn't have to be a 1. Because it could be only counting this one. Oh, I didn't even say what a vault is. These pink things are vaults, which you may not have seen before, and I will admit up front, I've never done a vault puzzle before. But the rule for vault puzzles is that digits can repeat in here as much as you want, which is good, because if you couldn't repeat digits in here, that would become a big problem. So you can repeat digits all you want, but any digit that borders a vault orthogonally can't appear in the vault. So these 3 cells, for example, never appear anywhere in the vault. So they obviously can't appear in box 4 in the vault, but they also can't appear in any of these cells. Okay. This 6 is interesting, because that's saying there's a whole lot of things here. Okay. What are these digits? That probably seems really helpful. These digits have to be pretty big. So this one sees at least 3. So now this one sees at least 3, and this one sees at least 3. So these are both not 2. Okay, Tallcat points out 6 by what I just said has to go here in box 4. Has to go here in box 2. Not there. I'll give the proof later after chat, or after the puzzle if people want that 6 doesn't go there. Box 7, I even hear, it can only go in one of these cells. And also, this cell cannot be a 6. Because if it was a 6, it would be saying it sees 6 primes, but that would have to include itself, which it absolutely cannot do. So the 6 has to go in one of these 2 places. Also, I'm going to take Niverio's suggestion that we color primes. So these digits are prime. This digit is not prime. This digit's also not prime. Let's see. 8 in box 3 is indeed placed, as Subu points out. Uh, it worked, afraid not, though I unsuccessfully ignored the message. So 8 can't be in the vault here. Okay, I love purple, but purple is going to be a nightmare because it blends so well with it. So I'm going to use yellow instead of purple in hopes for higher contrast with the pink. Uh, Medium. We'll go with that for now, but we will be open to other ideas. That's an 8, though. That's the point. Because if I put an 8 in the vault, I would be saying there's not an 8 here, but there was an 8 there. So that's green. Yeah, so this one's, yeah, they just see fewer than 9 cells. So, like, this one can't possibly now be more than 5. I don't know if it's worth pencil marking. This one can't be more than 5. This one can't be more than 5. Maybe I'll just mark these as saying they can't be more than 5. Because just by virtue of being on the edge, they can't be more than 5. It is not toroidal, to my understanding. If it had been toroidal, this would have probably been one of the puzzles where I'd been like, yeah, I'm going to let the LMD folks have fun with that one. Okay, so 8 now goes in one of these 2 cells. Okay. Let's see. 8 in box 6, I hear, is placed. Okay, so I'm trying to figure out which of these it can't be. And now I'm seeing a message deleted, so maybe Tall Cat has retracted the claim that 8 is placed here. So Ranks has a great point, which is that these 3 digits, whatever they are, can't appear in either this giant vault or this giant vault. I really kind of want to color the vaults, but I can't. But I would love to thicken these lines or something like that. So one of these 3 cells is an 8. I'll just go ahead and note. Because 8... Oh, no, that's not true. Never mind. Sorry. They don't have to be 8. Retract. But these 3 cells have to show up in there, over in that box. They have to show up in here, over in this box. They have to show up in here, over in this box, which is already interesting. So this is actually very interesting. So I'm going to try a coloring thing that's going to be a disaster. But we're going to try it. These 3 digits are orange. How many orange digits can there be in row 5? Well, there are 3 orange digits in total, so there can only be 3 orange digits in row 5. Now, what that means is that... Oh, no. Darn it. I was thinking that meant there had to be 1 orange digit over here and 1 orange digit over here, so that both of these digits had to be orange. But that's not actually true, because it could be that both of these are orange, and neither of these are orange. Oh, wait, no, it can't be. No, it can't be. Here's why. I need 3 of these to be orange. I need 3 of these to be orange. And so because I need 3 of these to be orange, I could do it like that. Except I can't actually make both of these orange, because if I make both of these orange, I break box 4. So it is true to say that both of these cells are orange, and both of these cells are orange. Oh, and I guess alternatively, you could just ask where orange goes in row 6, Tristan points out. But, that doesn't sound nearly as much fun. Okay. Now, definitely one of these is orange. But I don't really want to go to like gray orange slash coloring. That seems unfortunate. Let's see. What's the biggest? I guess we've seen here the biggest this that a Primesweeper clue can be is 8. But this one can't be as big as 8. What's the biggest this Primesweeper clue can be? It could see up to 4 primes here, and up to 2 primes. I guess it could see up to 3 primes here and 4 here. So certainly not more than... Oh, and it could itself be a prime. So I think this could be as big as 7, unfortunately. So that's not great. So maybe the question to ask is, can I possibly put 3 different primes into this vault? Because if I can't put 3 different primes into this vault, then these 2 cells have to be the same, which seems incredibly likely to me. So if I can't put 3 different primes into this vault... Sorry, so if I do put 3 different primes into this vault, what does that do? Not a ton, I'm afraid. I'm going to get rid of this orange coloring for now because as cool an idea as it was, I don't think it's getting me anywhere, and I think I need to focus more on what is and isn't prime. Okay. I think I should look at these numbers. Like, could this possibly be a 7? Well, it would see 2 primes here. Maybe it could be a 7. Oofda. Okay, so if these 3 are all different primes... Oh, no, because this cell doesn't even see the vault. Okay, so need to look at something else. So if there are 3 different primes in the vault, these 2 are the same. That's one thing we can definitely say. Because these 2 primes are both adjacent to the vault. But I don't see anything wrong with those 2 being the same. This one can't be 3 because it already sees 5 primes. So that I probably should have seen a while ago. Because all of these are things that it counts. So either it sees no more primes, in which case all of these become green, or it sees 2 more primes, and there are 2 more primes up here. Let's see, Tallcat is suggesting I look at row 7, column 6. And row 7, column 8. But they are not in squares. So yes, we could use the negative constraint if we knew more. I am a bit concerned about that there's going to be a really nasty application of the negative constraint to this ring shape that I may be supposed to know, but that I definitely don't. Niverio suggests thinking about where row 6, column 8 goes in box 9. Okay, so could go there. Go there. There or there? Let's see. Oh, box 3. Okay, box 3. It can only go in this column. So therefore, it has to go in one of these two. So what we're saying is, good point. What we're saying is because this cell can't go in this vault, it's only allowed to go in these 3 cells in box 3, and therefore it goes in one of these 2 cells in box 9. And so one of these 2 is prime. And so what that's telling us is actually none of these are prime. Okay. Note, this particular one is great because it happens to not be able to be 2. And so that means this cannot be prime anymore. And so it is a 1, which means that this is yellow. Sorry, which means that this is green, not yellow. This is yellow. So this is 2, 3, 5, 7. No, what did I do? What did I do? Rewind. People don't like it. Let's go over this again. Okay, so this... Oh, I was actually fine. It looked right to me. Okay. So now this thing sees more than 3 cells. More than 3 primes. So it's not 3 anymore. And so this is a 5-7 pair. So that's not 5 or 7. Okay, this thing sees 6. Oh, these aren't 1 anymore. Remember that row 6, column 8. Yeah, the row 6, column 8, those things are clones, right. That was what we concluded. I'll give them a black flash because it looks cool. And Ranksk is pointing that out to remind me that this thing cannot be 5-7 anymore. Okay. And so this thing shows up in one of those 2 spots. But I don't yet know where it is yet. Oh, did I do that wrong? One moment. Ah, yeah, it was this one that went up there and then down there. Okay. So that one gets the black flash. I thought I remembered, but I was over-optimistic about how good my memory was. We'll put it that way. So that sees its 1 and it's done. This one sees 4, so that's not helpful. I'm trying to use the negative constraint just to see, as soon as I have a square filled in, I should know the negative constraint. Okay, these, by the way, are 4, 6, and 9. But none of these see that many cells, I don't think. Okay. Row 8, column 7 sees both. Okay, yeah, good point, Andrew. This is one of my favorite things. Those 2 are the 2 flavors of 5-7. So this is not 5 or 7. It's 2 or 3. So one of these 2 is the other 5-7. So this 5-7 shows up here somewhere. Okay, so one of these sees 7 primes. Is that hard? Let's see. If this one tries to see 7 primes, it's currently seeing 5. It would need to see 2 of these. Okay, what about this one? Can this one see 7? Currently it sees 4. This one cannot see 3 more primes, which is what it would need. Because I would need to put 3 more primes around it, but all the cells that this has available to see are in this box. And I cannot put 3 more primes into a box that already has 2 primes. So that's the 5, that's the 7. So that's 5. So I can unflash these, though that was cool. So these aren't 5, that's not 5. There is a 5 up here somewhere. I'll go ahead and mark. Jessica points out that row 1, column 5 and row 1, column 8 can't be 5. Oh, that one, in the time since Jessica originally pointed that out, that has stopped being able to be 5. Why can't this one be 5? Is this some complicated geometry thing? Is it an easy geometry thing? I would love it if it was an easy geometry thing. Oh, yep, because there's only 4 primes. Good point. Yes. This only sees cells from one box. So it can't see 5 different primes. Great teamwork between Jessica and Tallcat there. Okay. Ranks suggests row 5, column 6. No, row 5, column 6 is a prime. And the reasoning for this is that I can't make both of these prime. Yeah, so good. So this is a shading game trick. So this 7 needs, remember, to see 2 more cells. And so the question is, could it see both of these? And the answer is no, because it would make this 5 see 6 things. And so if it doesn't shade both of these, it must shade that one. So that is a prime. I don't know anything about what prime it is, but it's a prime. Okay, and that's all of my primes for column 6. So all of these go green. So that's not a 5. Oh, and there are 3 distinct primes in this. Those aren't 7, by the way, so this is 7. Wait. Puzzles broke. What did I do? Oh, vaults don't have a non-repeating rule. I am just suddenly trying to something. But there are in fact 3 distinct digits in this vault. It's just not the case that none of them are 5. I was trying to use killer cage logic, but this isn't a killer cage, blah blah blah. But these can't be 5. Oops. So let's make them both 5. These can't be 5. So this is 5. That was that done in a way that was less completely wrong. Okay. So now nothing that sees this vault that also sees a 5 can possibly be prime. So those cells are all composite, or 1. So that's good. So that's some extra shading done. And so now this 5, I guess this 5 has 2 options for where it's going to get its second prime. Oh no, this 7 only has 1 option for where it's going to get its second prime. Where it's going to get its 7th prime. It has to go there. So this is a 2 or a 3. This 5 now sees 5, so that is not prime. Okay, there is a prime in here somewhere. It's the other 2 or 3. Let's see. Chat is talking about some stuff. Oh, Niverio is suggesting what the Sudoku would look like where there were no repeats in this cage. I think it would make the puzzle a lot easier. Because think how many digits that would be. Okay. Okay, so you can remove 2 and 3 from row 1, column 6. That was one of the claims. Okay, so this can't... Oh, yes. I was like, I'm going to wait to look at that one because that one sounds really complicated. But then it turned out to not be very complicated because it turns out that there's now a 2 and a 3 in the column. Okay, I'm going to go ahead and fill out candidates for the rest of this column. 1, 2, 3, 5, 6, 7, 8, 9. And 4. I just didn't list 4. That one's not a 1. That one's not a 1, for that matter. Okay, so this sees 1 or 4. If it saw 4, that would have to look exactly like that. Those would all be shaded. And that's not possible, because that would put too many primes in column 7. So this is not a 4, it's a 1. That's not an 8. That's not a 1 anymore. That's not a 1 anymore. Okay, so this needs to see at least 2 primes, which is interesting. It can see at most 1 prime here, but it could see both primes over here, or it could see like 3 primes somehow. What I'm trying to do here is I'm trying to decide if fulfilling this clue is automatically going to fulfill this clue. Oh, if this is a 2, sorry. If this is a 2, it sees itself. So if this is a 2, it could see a prime there and a prime over here and be done. But here's a point I have not considered yet. I have to put 3 more primes in this column. And so those primes include a 7. So one of these 2 is a 7. And then, so if I know that 3 of these are prime, in fact, exactly 3 of these are prime, yeah, I guess that's technically okay. So people are asking about, can this be 4, which it definitely can't for exactly the same reason this one couldn't be 4. Oh, which now means it's prime. Ah, okay. So I was like, why do I care if it can't be 4? I mean, it's almost certainly not 4, but now I see why I care that it's 4, because it being 4 makes it the last, or sorry, it not being 4 makes it the last prime in the column, which greens those. It gives us a 2, 3, 7 triple, etc., etc. Okay, so this sees at least 1. Okay, this actually in reality sees at least 2. Oh, but it has to see at least 4 because it's composite. Unless it sees exactly 1, which it cannot see exactly 1. Okay, so this cell cannot see exactly 1 prime because 3 of these numbers are prime. And it already sees that one. So this digit actually has to be quite large because it can't be 2 or 3 because then it would be prime and there aren't any primes in the column left. So this is at least 4. I'm going to bet it can't be 6, but I'm going to briefly entertain the possibility that this is 6, which would require these be prime, and I find 1 more prime for it to see, which I can't possibly. So this is a 4, for sure. That's not a 4. Okay, so that's not a 4. Okay, so this is going to see lots of primes, and it currently does not see very many primes. Oh, this is a 2, 3 now. Same logic as before. And now the green, now this is done. Okay, and so now the 4 can only possibly see 4 primes. So it's those. So that's a prime. That's not a 4. Let's see, that's a 2-3 pair. It's a 5. There's a 7 up here. Let's see. This is a 2, because now it's done. Oops. So it makes that a 3. So it's not done. It needs to see another prime. And so this is not prime, because the primes are done for the column. So that's a 7. That's not a 7, because 7 is composite, and because there's a 7 in the column, and because of whatever other reason you want. So that's a 3, so this is a 2. It already sees 2 primes. Oh, I just knew this was a 5 already, because I'm done for primes in the box. I just didn't see it. It was one of those rare moments where I seemed to be getting stuff done, and then I just wasn't paying attention to chat, who I'm sure was pointing out all of those things, which I appreciate very much. Okay, so this 1 needs to see a prime over here somewhere. Good to know. Let's see, I think I want to try a little bit of Sudoku over here before I move on to the coloring. Oh yeah, there's absolutely going to be a completely heinous negative constraint at least one point. Okay, so what's left in this box? 1, 3, 4, 6, 9. Okay, these aren't 1. That's not 4. It's not 6. For some reason, I was immediately inclined to shade the 1, 9. I don't know why. I guess I somehow thought I was doing a sandwich Sudoku. Let's see. This can't be 4. Oh, this is a 3, just by looking at the box. So that's a 2. So these aren't 2. That's not a 3. These are a 3, 7. Okay, let's see. Let's remember what things can't go on the border of this box. Oh yeah, that's really cute, Ranks. The center cell can never be 4 unless it's in a box. Because it would see exactly 4 primes. Okay, so this 1 means one of these 2 is prime. What's the most this can possibly be? Oh, well, it can't be a 2. That's a good point. So this has to be at least 3. And so this being at least 3 means that both of these are prime. Because exactly one of these is prime, this cell tells us that. Right. And so this needs to actually be 3. It can't be 4. So it is 3, and it is also prime. This being prime means it's not 6, as people have previously tried to tell me. This isn't 6, because of the 6s in the row. So let's see. So this is... These are 2, 5, 7. That one's not 7. Okay, is there a universe where... Oh, I know that this is composite. I don't know why I didn't color it immediately. Let's see. So is there a universe where this is a 5? Oh, it has to be a 5, because it already sees more than 2 things. I didn't think it could possibly be a 5, but it has to be. So that's not a 5. It's not a 2 either, because of looking at the row. Okay, so this 5 now has to see 1 prime over here. The 5 definitely sees exactly 1 prime down here, so that brings the total to 4. So one of these two is prime. I'm going to denote that like that. Exactly one of those two is prime. I don't think I immediately know which one. Okay. But one thing I'm noticing is that 5 appears next to this vault, and so 5 can't go in this vault, and so 5 is up here with its friend the 6, which is, I think, what Ranks was pointing out, but I was not paying close enough attention. Okay, yeah, and in box 5, now this Ranks definitely did point out, 5 in box 5 can't go in this vault, and so it can only go here owing to Sudoku. So those aren't 5. Well, I was looking at box 4 on my own, and then I noticed that you were talking about box 5, so then I moved over there. But I had seen something about vaults and 5s, so I figured probably I was just seeing something that chat had seen an hour or two ago. Let's see. Okay, so I want to mark candidates around this vault because I want to see if I can figure stuff out around this vault because I would like to know what's in this vault for purposes of looking at this. So we need a 1, 3, 4, 5, 6, 7, 8, 9. Okay, these aren't 1. That's not 8. Yeah, so this vault sees 2 of these digits. So this digit has to show up in this box. Whatever it is. I'm going to give this a black flash now. Where does this digit show up in box 6? Well, it can't show up any of those places. It certainly can't show up there because that would be bordering it. So this digit is one of these 2 digits. It's either a 4 or it's that digit. Okay. If it's a 4, it goes there. If this is that digit, then it goes there. Okay, maybe this did not actually lead me anywhere. Apologies. I think this was a long dead end. I think it's the right kind of question to be asking, but it was not a profitable question in this instance. Let's see. 5 in column 3, I hear tell of. So 5 can't go in this vault. 5 can't go here. 5 can't go here. So it looks like 5 goes there. Excellent point. So that's not a 5 anymore. Let's see. Look at box 8 and the 2 cells that border the vault. So the vault does contain every prime. So these 2 can't be prime. They are composite. That is Ranks' point, I believe. It certainly follows from Ranks' point either way. Sorry, I'm just double checking for negative constraints again. So these can't both be prime, because if both of those were prime, it would make this 5 correct. And so what that means is one of these is prime. Actually, sorry, maybe neither of them's prime, because it could be these are prime. I think, as far as I can tell. Let's see. That would be make these a 2-3 pair. That seems fine. So almost this 5 I'm going to mark just because its negative constraint's actually going to tell us something at some point. Okay. Yeah, neither big vault can contain a 5. That's true. I have 5's pencil marked here. Is there something else I can look at from that? Because the 5 in this box, for example, can't go any of these places because of that. Oh yeah, the small vault even can't contain a 5. Uh, okay, so this row already has 4 composites in it. So 4 of these 5 numbers are prime. Uh, what is that doing for us? Anything interesting? Well, it means the absolute minimum of this is 2. Oh, 5 is prime. Why have I not colored that 5 is prime? Don't answer that. There's not a good explanation. But yeah, there's still 4 primes as of yet to appear in this row. So if this wanted to be a 2, it would see 2 primes. This would be the last composite. And then these would have to both be prime, which would finish the primes for the box. But that seems a priori okay. Let's see. I hear from Masubu that I have an X-Wing on 6 in row 8 and 9. Ah, yes, excellent. So 6's align in these 2 boxes because I have them marked. So there's a 6 in one of these 2 cells. And I think 6 is one of my digits that can't go in the vault. Maybe 6 can go in the vault, actually. It's that vault that can't have a 6. This vault might be able to have a 6. But one of these is definitely a 6. No denying that. And so this is not a 6. And so now one of these 2 is a 6. Let's see. We want to think about 6's in box 5. So I can't put a 6 in the box, in the vault in box 5. Let's see. Ostensibly, I could put a 6 here or here. Let's see. I really want to think. Does 6 just break this box? So if I put a 6 in the vault anywhere, that's not quite true. If I put a 6 in the vault, if I put a 6 in the vault here, then it forces... I can't put a 6 in either of these places. Why? What's going on? See, I definitely can't put a 6 anywhere in here. That I know. I can't put a 6 on top of one of the primes. That I know. Why can't either of these be 6? Oh, that's amazing. Okay, that's gorgeous. That is gorgeous. Okay, if I put... Thank you for explaining this to me. If I try to put 6's here, I get an X-Wing pattern, which either looks like that or like that, and either way, it's broken. That's gorgeous. Okay, that is really cool. So, can't put 6 in this vault. Because of that weird X-Wing thing, can't put 6's there, so have to put a 6 there. So that's a 6. That's not a 6. Okay, and now 6 can't go in the vault, because now it is adjacent to the vault, so that's not a 6, and so that is a 6. That is very cool. And so now that's a 6 by good old Sudoku. Let's see. I hear 6 in box 2, but I beat Tall Cat to that one. Those rare moments where I see something before someone else. It does not happen often. Let's see. I know, like, absolutely nothing about this vault, which is notable. Okay. I never actually got around to looking at this 5. Did I? Yeah. One of these two is prime. I know that. So yeah, this 5, I guess I did look at this 5. One of those two, oops, one of those two is prime, one of these two is prime. In fact, one of these two is a 2, if I wanted to be even more specific. So one of these is a 2, one of these is a 7. I hear something about 6s in box 3. Let's see. Ah, yes, because 6, again, I did not dutifully remove all the 6s from this vault like I thought I did, because that can't be a 6 anymore. And so, therefore, that's a 6. Which then bounces down here, removes 6 from there. And so now I have 6 in one of these two cells. Let's see. 6 in row 6. Not there, not there. Not any of those places. Beautiful, beautiful, yeah. 6 in row 6 is hidden there. That is a great spot, Isubu. Okay, so that gives us a 1-9 pair in column 8, which places a 6 there. This isn't a 6. You could also say this isn't a 6 because we just put a 6 there. But now we have a 4-9 pair, so this is an 8. Let's see. Okay. That 8 removes an 8 from there. So I have a 1-9 that's in the vault and a 1-9 that's not in the vault. So I think I want to color these. And maybe I can get a thing to remove there. Because these two have to be the same. They can have an orange flash. And this is the other one. This is the one that's not in the vault. Blue. That was not as cool as I hoped it would be. Because I don't think I can quite see. Like, orange has to go over here somewhere. Orange. It's up here somewhere. Let's see. Do I see anything else bordering this vault that's interesting? Let's see. There's definitely an 8 bordering it. There is a 4 in it already. Let's see. Row 9, column 2, and the prime composition of the bottom rows. Let's see. There is 1 prime up here somewhere. It could be up there. But I note there's 3 primes down here left to place. So what's the minimum I could put? I could put a blank there. So this would be not prime. This could be prime. And these two could be prime. Ah, but then that means I can't make this prime anymore. Oh boy. Okay, so that's complicated, but I think I see it. So if this is a 2, that says there's 2 total primes in these 6 cells. Now, how many primes am I expecting in the last 2 rows? I'm expecting 8. So if 2 of these only are prime, then what happens? Then I get 2 there, plus 3 there, that's 5, and so I need 3 more primes, which would have to go there, except, no, it can't. So that can't be 2 anymore. That is very hard to spot, at least for me, but it is a very good point. Rank says row 1, column 9, sees a 1 and a 9 through red and blue. Row 1, column 9. I'm trying to see how it sees a blue. Yes, exactly. This has to be... Yeah, okay. So this is... Yeah, so this can never be blue. So if it's a 9, it's orange, but it can't be orange. So this is a 4. That is an excellent point, Ranksk. So that's a 9. That's a 4. Let's see. So that's not a 4. And I get to continue coloring, which is all I've really ever wanted to do. So that's a blue 1, 9. Let's see. Okay. This vault now has a 4 in it. Does that buy me anything anywhere? Oh, the vault already had a 4 in it, so no, it does not buy me anything anywhere. Okay, so 8 down there. Oh, there's a 4 in the row, so this is a 3. That's good. Okay, so now I think we can play the game that we played before of count the primes in rows 8 and 9. Because there's 3 primes in there, 3 primes there, so there's 6. So 2 of these are prime, exactly. And if 2 of these are prime, that's all the primes in this box, so that's composite. Okay, so that's something. So that was a fun game. I hope I get to play that again sometime. Let's see. 3, 5. Oh, there's a 6 looking at my 6 pencil mark down here. So that's a 6, and 6 is not prime. Let's see. Ranks wants me to look at row 1, column 3. Because if it was prime... Oh, wow, that's a good spot, Ranks. If this was prime, what prime would it be? It would have to be 5. But it can't be 5, because then I'd have a 5 in and out of this little tiny itty-bitty vault. Oops. Oh, you can draw in lines now? Oh, sweet. Okay, so I actually could have gone around all of these to start and done the thing I actually wanted to do. But now that will give me new ideas for beautiful, wonderful things that I can do with the software. So that's the prime that this sees out of those 2. Because remember, this 5 needed to see 1 prime in this pair and 1 prime in this pair, but Ranks just offered a beautiful proof that this is not prime. Okay, so this is a 2 or a 3. This is an 8 or a 9. Okay. Yes, it is. It is very, very mentally tricky. Hey, grkles. I think you've made it to a live stream. Let's see. I can play 6 in box 4. This is box 4. So I can play 6 in box... I can play 6 in box 4, but not there. I can play 6 in box 4 there. So that's composite. Let's see. That 6 is already there. It, on the one hand, feels like we're almost done, and on the other hand, I know absolutely nothing at all about this vault. which makes it feel like maybe I don't almost done. Okay, so where is 2 in box 4? It can't go here because of the 2 in the row. It can't go there because it would be next to the vault. So 2 is in one of these places in the vault in box 4, and it's a minor deduction, but a deduction nonetheless. Though it might actually be so minor that I don't even want to write it down. I haven't looked at this 6 clue at all, but I guess I also haven't learned any of these things are composite. Let's see, I should write out the rest of row 1. Let's see, row 1 still has a 5 in it, and an 8 and a 9. Which is interesting. Okay, this is a 3. So again, we know there's 2 of these 3 cells are prime, but I don't yet know which 2. Let's see. I continue to know there's no 5 in this vault, but I don't think that's useful. 2 in box 7, I'm encouraged to think about, because I can't put 2 there or there or there or there. So yeah, 2 in box 7 has to go there, which actually does gives us that. Let's see. Okay, so 3, 7. So yeah, so the 2 in this box is up here. So that means the 7 in this box is in one of these 3 places. Because this needs to see one more prime, and it can't see the 2. Or alternatively, I suppose, because there's a 3-7 pair there, but whatevs. But in particular, that means this cell's composite, because we've accounted for both the 7 and the 2. So this is a composite that the only thing I know about it is that it's not 6. Nudges are hard. I'm just happy if someone asks me how to do one of my puzzles and I actually know the answer. Let's see. 3 we know is in one of these 2 cells, but I don't know that that's super helpful. Yeah, if 2 is here, that's fine. Okay, so grkles, who I have reason to suspect knows what's going on with this puzzle, wants me to look at this. So this cell is at least 1. But it could be as big, I think. Let's see. Oh, it can only possibly see one more. Actually, it can only possibly see one more prime because there's only one more prime to give in this box. In fact, it does see a total of 1 prime from this box. Okay, because exactly one of these is prime. And this definitely sees it. So this is at least a 2. But it can never be a 2. No, it could be a 2. I think. I think. Because then it would be the other prime, and so it would see these 2, and all of these would be composite. Oh, these can't all be composite, because that's too many. Wait, is it? Column 3, I see at most 2 of these are prime. Oh, okay, but I can't fit all the other 2 primes down there. That's the point. I can't put 2 primes in this cell. I'll save that for the next grkles puzzle. So yes, this can't be a 2. So it's at least a 3, and it's a 3 or a 4. Oh, and it's not a 3 because there's a 3 in the row. And it can't possibly be more than 4. The reason for that is because, again, it sees exactly 2 primes here. I don't care whether it's this one or not. It sees exactly 2 here, and then it sees either 1 or 2 more in these 3 cells. But if it saw one more, that would be a big problem because I would be putting a 3 in this square, and there's already a 3 in the row. So I have to put 2 primes in that strip and make that a 4. And once I put 2 primes in this strip, that means I don't have any primes left to put there. So that's not a prime, and it's not a 7. Oops. And it's not a 7. This isn't prime because it's a 4, and 4 is not prime. Okay. There's something about a 2-3-7 triple. I don't think I completely get the 2-3-7 triple thing. Let's see. Okay, so yeah, I don't let's see. Okay, so where does 7 go in box 5? Maybe that's the question I'm supposed to ask. It's either going to go there or there. But I don't think that is helpful. Oh, 7 in box 1. Okay, so this is way less complicated than I was trying to make it. I know these 7s are here, so this 7's not here. So this is a 7, which is a prime. Which doesn't tell me anything immediately. Because this is not in a square. Let's see. And so now can I look at 7 in this box? Oh, it's not there either. Okay, so 7 is definitely in this vault because those are the only 2 places that 7 can go. And so the point is 7 is in the vault, so 7 can't be outside the vault. Oh, you're welcome, Eleventicles. So that places the 7 here, which is prime, which makes this a 3, and that a 7, and that a 3, and that a 2, and that a 7, which makes that not a 7, which makes that a 7. So long string of Sudoku ensues. Okay. So this cell can't be can't be prime because it already sees all the primes. So this cell is composite. Let's see. The same is true of this cell, actually. This also sees all the primes. So this is composite. And so this is the only cell in the box that can be prime. And it has to be the last prime, so it's 3. Riff Clown is suggesting that I look at 7 over in this box. Yes, 7's placed there. Let's see. This has got to be prime because it's the only remaining place for a prime. So that's the 2. This is composite. This line can go away. Okay. And so row 8 means that's composite because now I've got all the primes in this row. This box still needs a 2, so that's a 2. So that is composite. And in fact, it's an 8 or a 9. Let's see. So yeah, I know one of these is a 2. I don't think I know which one yet. Let's see. What else is here? Let's see. 1 is somewhere in this whole mess, but that's not super helpful. Okay, this column. Let's see if I can get anywhere with Sudoku in this column. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too many. I put a 5 there, even though there was not a 5. 4. Let's see. That one's not a 9. In fact, this row has 1, 4, 8 left in the row. That one's not 4. Let's see. So there's a 4 in the vault, so that can't be a 4. So that's a 1-8 pair. And that being a 1-8 pair is actually huge because that means that this is a 9 And this is a 4. That's not a 4. Let's see. This being a 9 makes that a 4, and that an 8. So we're done a column. That's always good. Let's see. The rest of this row is a 1, 9, and 3, and a 4. Well, that one's not the 4. So that one's a 4, which, by the way, is composite. And this is the blue 1, 9 of flavor. The blue 1, 9 of flavor sounds exciting somehow. Okay, but the blue 1, 9 of flavor is now in a box with a 1. So the blue 1, 9 of flavor is a 9, which makes the orange 1, 9 of flavor a 1. And we can remove our blues and oranges. Okay. So left in this row, we still need a 2 and a 3 and a 1. So this is 1, 2, 3. And that one's not a 3. Okay, scanning. Let's see. This still needs to see 6, and it's not seeing 6 yet. It's currently seeing 5. So exactly one of these two is a prime. I don't know which one. Let's see. Row 6, column 5, I see someone say. Let's see. So this is in the vault, so it can't be a 9 or an 8. Yep, can't be a 9 or an 8, so it is a 1. Huzzah, good catch. That's an 8, that's a 1, that's a 4. Let's see. It's not a 1. This is an 8 or a 9, but I must know which one. It's an 8, so that's a 9. Okay. So 8 now can't go in this big vault either. So 8 has to live up here somewhere. Joining its friend the 5, although I realize now that that's just like Sudoku, man. Let's see. So left in this row, I should go ahead and fill in because I only have a few things left. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's too many. There we go. Let's see. So these are 1, 2, 9, so that's an 8. Okay. Do I know anything about 1s and 9s with regards to this vault? Yes, there's a 9 in this vault, and so that's not a 9. Let's see. What's left in this string? Let's see, it's a 3, 4, 5, 6, 7, 8, 9. Okay, that's not a 4. Oops. I don't know what I did. It's not a 4. That's not a 4. So that's a 4. Okay, and yeah, there's definitely a 9 in the vault, but that's not super immediately helpful. Scanning. Let's see. 5, 8. Okay, so this is down to 2 things. I might as well fill in what they are, and maybe the vault will help me. 1, 2 is what they are. So one of 1 and 2 is in the vault, and one of 1 and 2 is out of the vault, but 2 is already in the vault, so 2 can't go here. So that's a 1, that's a 2. So that's a 2, that's a 3, that's a 9. What on earth is going on in this column? There's a 2, so that's a 1. There's a 9, so that's an 8. Let's see. Oh, ranks has spotted the negative constraint, so I'm going to just pause and immediately do that. Row 7, column 2 can't be prime due to the negative constraint on Uh, row 7. Ah, yeah, so this is not 2 or 1, so it is 9. Or apparently this is really eager to fill in 0. So let's see. 1, 9, so that's a 5, that's a 9. That's an 8, that's a 5. That's a 3. That's a 1. Okay, I don't think we actually had to use the negative constraint anywhere in there. Nice puzzle. Oh, well, I could have, sure. I was just expecting to have to do something really heinous with negative constraints and this sort of shading geometry, which I did not have to do. Yeah, that was a very fun puzzle. I enjoyed it as I thought I would. Okay, let's see. I think I have time for one more puzzle. So I think I am going to do Minesweeper by Niverio, continuing the sweeper theme of today, seemingly. It's funny because the next puzzle of mine that I paused over is a Minesweeper puzzle. Don't worry if you're really excited to get back to me doing my own puzzles. I will do that soon. Okay, so here are the rules of this puzzle. We're supposed to put some digits 1 through 9 into the grid so that they follow ordinary Sudoku rules. But some of those digits are mines, and that means that they are counted by the circles, which are always Minesweeper clues. Okay. So this is telling me that 2 of these digits are mines. Okay. Note, just to confuse me, exactly unlike the previous puzzle, the circles do not count themselves. So, in other words, this is not telling me anything about whether 2 itself is a mine or not. It's just telling me that of these digits, 2 of those are mines. Okay, so we have to deduce which digits are mines. And once we've deduced which digits are mines, we can finish the puzzle, and all possible circles are given. So this circle I see right away has to be a 1 or a 3, because it just doesn't see more cells than that. This one sees as many as 5 cells. Likewise, this one. Let's see. Likewise, this one. Kind of funny how there's 2s looking at everything. Likewise, this one. This one doesn't have a 2 looking at it. I don't know what to do with myself. Okay. So, oh, this one has a 5 looking at it too. So, tall cat, we have to decide for each digit whether it's a mine or not. So, in other words, 6s are either all mines or all not mines. And then the circle, if 6 is a mine, will get counted. And if 6 is not a mine, will not get counted. Let's see. Unfortunately, all of my other cells or circles are seeing lots of things. Okay, so I know there is at least 1 digit that's not a mine. Okay, I think probably I should pay attention to the fact that there's lots of given 2s. Okay, so this circle definitely sees a 2. So if 2 is a mine, it's counted by this circle. That seems like a good thing to know. Likewise, if 2 is a mine. So ranks, yeah, I was noting row 5, column 5 is the number of mines minus 1 if it itself is a mine, which is confusing. But I think might disambiguate it. But we know there's at least 2 mines. So we'd know this wasn't a 1 almost. I guess we know there's at least 3. Maybe we don't yet know there's at least 3 mines. Bye, grkles. Sleep well. Okay. So where is the 9 in this column? It's not in a circle, so the 9 has to go in one of these places. I would really love to be able to say something as dumb as there aren't 8 mines. I know there's never a 9 in a circle. So one of these 3 cells is a 9. I don't know if that's worth highlighting. Yeah, let's see. Okay, are there other digits? There's 8s everywhere, so there's an 8 over here somewhere. Interesting, interesting. Okay, 5 is in this T. Unfortunately, this being 5, I think tells me there have to be at least 3 mines. So there are not 2 total mine digits. There are at least 3 mine digits because this 5 sees cells in only 2 boxes. And so if there were only 2 mine digits, it could not be more than 4. So there are at least 3 mine digits. I have no idea. There's probably more than that. But I'm not sure yet. Okay. So, no, that's not quite true. I'm looking for mines that see basically the same cells, but not quite. But I can't quite find any, because this one doesn't see that cell, for example. Okay, so this 6 at the center of the box is telling me the 6 does not see 6 mines. So either 6 is a mine or there are not 6 mines. Because it's not circled, and we have to pay attention to the negative constraint. Okay. I think I may be supposed to be paying attention to the 2s with a negative constraint. I'm not 100% sure what I'm supposed to be doing, which is a very generous way of saying I have absolutely no idea what I'm doing with this puzzle. But the 2s are telling me there's not 2 mines that they're seeing, which probably means there's more? I'm not sure. I wish I knew whether this was a 1 or a 3. One of these is at least 4, which is interesting. Okay, so the thing I see with the circles in box 1 is that one of these is a mine. Because if none of those were mines, these 2 would contain the same digit. Okay, if this is a 3, then this has to be a 4 or a 5. Right? Yeah, so if this is a 3, this sees 2 things already. So it cannot possibly be a 1. It can't be a 3 by Sudoku. And so then if this is a 3, I need at least one of these to be a mine. On the other hand, if this is a 1, then this is at least a 3, and it sees at most one of these, so there has to be a mine there. So I think, and perhaps this is the minor deduction that 57 was referring to, I think I have concluded there's definitely a mine in one of these 3 cells, which is not great, but is technically something. Let's see. This is not 1. Yeah, okay, so if this is 1... Yes, okay, that's beautiful, yeah. If this is 1, then at most... Well, then exactly one of these cells is gray, so this can't possibly be 3 anymore. So this is not 1. I agree. I also colored this light gray because I accidentally hit the 1 button when I was in the wrong mode. So if this is 3, then 2 is a mine. I don't know if that influences my thoughts a lot. Likewise asks if it has to be that 2 of these cells are mines. So I think this could be 3 and this could be 4. And if this is 3 and this is 4, I think it could be these are mines and say that's a mine. Oh, wait, no, you're right. Okay, I think you're right. So if this is a 1, then I could have one of these and I still need... Okay, yeah, so that's a good point. Okay, excellent point likewise. So my argument's actually better. Actually, 2 of these, at least, are mines. Yes, a foot is 12 inches. To those of you who are measuring something in the chat, I probably shouldn't dig too deep into it. So, really, at least one of these is a mine. Also. So, 2 of 3 gray cells are mines, at least. And also, at least one of these is definitely a mine. Which is, again, not the best of these things. I was trying to make my chair lean back, and then instead of making my chair lean back, I was almost pulled the piece off again like I did last stream. Let's see. So the 2 in this box is here. There we go. Ha ha ha. Okay. Hopefully that didn't screw with the camera too much. I could just tilt this down just a tiny bit. I don't think Niverio is here. Column 5 seems interesting since there are 2 circles in the centers of the boxes. Oh, that's a good point. So likewise points out one of these 2 has to be a mine, and one of them is not. And the reason why that is if these were both not mines or both mines, because they're in the same column and they're in the center of the box, they would see the same number of mines. So this is one of each. I don't know how on earth I wanted to note that. We'll try that, I guess, question mark. Okay. One of these 3 numbers is at least 4. Yeah, one is a mine and one isn't. That's the conclusion. One of these is at least 4. which means I am not using light gray, dark gray for what is a mine and what isn't a mine. I'm just using light gray and dark gray to mean these cells were interesting in some way that I don't have any idea how I'm notating anything in this puzzle yet. I basically it's just, okay, this is a different thing than this over here, which is a different thing than this line, because I have no idea how I'm supposed to notate this information. But I'm hoping that as I make progress in the puzzle, I will reach a point where I actually know something. Okay. So if this is a 5, is that a problem? Because if this is a 5, we're saying all of these are mines, which is to say there's 5 non-5 mine digits. Say that 10 times fast. I don't yet see why that can't happen, though. Okay. There are only 4 options for these center cells now. Let's see. So, okay. So there's not 1 mine, and there's not 2 mines, because one of these is at least 3. So there are at least 3 mines. So these numbers have to be at least 2, but they're not 2. So these could be 3, 4. They can't be 5 or 6. And they could be 7, 8, or 9, but we can immediately dismiss lots of those. So they definitely can't be 9. Because if they were 9, then what would that do? If they were 9, then that would say that there's more than 8 cells in the 8 surrounding cells. Okay, so it's not 9. Could it be 8? I think that's unlikely. If one of these is 8, it's saying that every non-8 digit is a mine. And so, for example, if every non-8 digit is a mine, all 3 of these would be mines, and this would be a 3, which it's not. So these are not 8. Okay, now we get into the harder part. These 2 are 1 apart. And because these 2 are 1 apart, neither of them can be 7. So they are a 3-4 pair. Great. Okay, perfect. So now we have progress. And so now we can pencil mark this column to reward ourselves. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Good night, Joe. It's an 8. Okay, so this number is either 1 or it's enormous. Yes, and this is a good point. So exactly 1 of 3 and 4 is a mine. And the number that's a mine is 3, because the 4 sees 4 mines. Yeah, so the bigger number, so the 4 is, so 3 is, so 3 is a mine and 4 is not a mine. Does chat agree with me? I admit that was complicated to do in my head. Night, Chili. Or silly, as apparently this thing is. Okay, so 3 is a mine. I don't know if I wanted to note that somehow. 3 is a mine, 4 is not a mine. Okay. So 4 numbers are mines. Okay. This is definitely not a 9. Yeah, there are 4 mine numbers. So could this C 8 total mines? No, because it can see at most... Oh, crap. Could it see 8? Could all of these be mines? I unfortunately don't think I could rule that out. In fact, it might actually be harder for this to see 1 mine. Actually, both things that this could be seem really difficult to make happen. Okay. Oh, okay, so it can see at most 4 here, and at most 3 here. Okay, so this definitely can't be 8. And so it could see 4 mines there, and 3 mines there. And that would not work. Yeah, so... Sorry, and that would work, technically. I'm sure I'm great for homework. Let's see. So this 5 sees 5 of the 4 mines. So it has to see a digit twice, at least. Maybe it sees 2 digits twice. But I don't yet know. Okay, so in this column, in every row, column, and box, in fact, there are 4 total mines. Is there any way I can deduce anything about where those are from this 5? I fear not. The 8 in column 5 is placed. Oh, yes, because I never noticed that 8. And so that's an 8. Let's see, 2 of these are mines. Okay, so if this is a 3, it sees almost... Oh, if this is a 3, it sees all the mines in the box. Because if this is a 3, it is a mine, and it sees 3 mines. So that seems important. So if this is a 3, then all of these are mines, and all of these are not mines. And that doesn't work, I think. Okay, I'm going to get rid of this coloring that was nonsense. I'm still going to leave these colored in this weird way, just to remind myself that those are the interesting ones. Yeah, neither 3 nor 4 is at the center of any box. That's a good point, unless there's a circle. So I guess Ranks is suggesting we good lift these as 1... Oops, not like that. As 1, 2, not 3, 4, 5, 6, 7, 8, 9. And then go back and say, okay, that's not 2 or 8. That's not 7, at least. That's not 2. Somehow I managed to hit a digit that wasn't there instead of a digit that was. Okay. This is not 8. And that's not 8. Okay, in fact, I know the 8 is there. But hopefully this will work. Okay, excellent point, 11 tickles. This can't be a 5, because it would be saying it sees 5 mines in these squares, but there are only 4. So that is very helpful. So now I have a 1, 3, 4 triple in the row out of nowhere. So one of these is a 1, and one of them is a 3. Sorry, one of them is a 1, and one of them is a 3 or 4. Okay, so these aren't 1 anymore. And that one's not 7 either. See, this is already paying off. Okay. Okay, so whichever of these is a 1, sees one total mine in all of these cells, plus possibly as a mine itself. So either all 3 vertical digits are mines, or 2 of them are. Which is interesting. Okay, I think we've learned this can't possibly be a 7, haven't we? No, because this could be a 4. These could all be mines. And then these could all be mines. And that's nominally possible. That would be the 3. Okay, is there some way I can rule out all of those being mines? Because that's what it would take. Exactly all of those being mines is what it would take for this to be a 7. Okay, if this is a 5, someone is saying, likewise is saying that something goes wrong. So Tristan is asking, why couldn't the 3-4 go the other way in that case? Because in that case, you've got 3 bombs here. Oh yeah, okay, you could have 3 bombs there and 3 there. Okay, I guess technically it could go that way. Okay, so can this be a 5? Is one question. So if this is a 5, all of these become bombs. And then both of these are at least 3, so they have to be a 3-4 pair. So if this is a 5, these are a 3-4 pair. And this being a 4 means that none of these are bombs. This seems plausible, from what I can tell. That's too many bombs in box 1. Let's see. Both Tristan and Tallcat are telling me, and likewise are telling me that's too many bombs in box 1. Okay, so let's see. Okay, so if this is a 5, it would look like this. This would have to be a 3. Ah, but this couldn't be a 3, because if this is a 3, I have to put a bomb there, and that's too many. Okay, so this is not a 5. That's the point. And so I now also have a 1, 3, 4 triple in this column. Okay, interesting. One, 3, 4 triples for everyone. Okay, so these numbers are all big. So they're all 5, 6, 7, 8, 9, and that one's not even a 5. That one's not an 8. Okay, if this is a 3, it eats up all the bombs for the box. Does that matter? Okay, so I'm hearing if this is a 3, that also breaks. So if this is a 3, then these are the bombs for this box. This is a 4. Those have to be bombs. And now this is a 1, and that does not work. So I believe Tallcat is correct. So let's do this one more time. If this is a 3, all of these are bombs. The bombs are done for the box. This is a 4. It can't see that as a bomb, so it must see these 2 as bombs. But now this is a 1, and that doesn't work. So this is not a 3, it's a 1. So this is a 3-4 pair, which means that's a 1. Uh, So whether this is a 3 or a 4, none of these are bombs. So we actually get to color some places that are safe to walk, finally, after 157 minutes. These are all not bombs. And so 2 is never a bomb. So those are not bombs. Oh, wait, which means 5 and 8 aren't bombs. Bye, Kurabon. This 1 means there's only 1 mine in all of these cells. Sorry, there is 1 or 2 mines in these cells. And so there are 2 or 3 mines in these cells. I don't think we can conclude they're both bombs, though. Yes, at least 1 of 5 and 8 is a bomb. I definitely agree with that. 5 being a bomb seems hard because it means when there's 5s in circles, which there is more than 1 of, it doesn't count itself. Well, I guess this one could count itself there and there, maybe. Hard to say. Okay. So this being a 1 means there's 1 or 2 bombs here. So there are 3 or 4 bombs around here. See, 1 low things being bombs makes sense, because a 1 being a bomb, for example, would make it really easy for there to be a 1 in a circle. Let's see, where can 1 go in this box? Okay, so 1 is in one of these 3 places in this box. Could this possibly be a 1? That seems like a very heavy lift. If this is a 1, it says only one of all those cells is a bomb, because this one wouldn't itself be a bomb. And we know either 3 or 4 of these are bombs. So if this is a 1, then we'd have to do... I guess not. I guess it's okay, technically. Now, I do know I still have to fit 4 bombs in this column. Which means I have to put at least 1 bomb up here. Okay. So I think that's actually huge. I have to put at least 1 bomb up here. Oh no, never mind. Let's see. So this is a super cool puzzle too. I am enjoying the collection of puzzles today. So much like 2s, 8s join this collection for whatever good that's worth. It just seems so hard for me for this to be a 1. But it also seems hard for it to be a 7, which is unfortunate. Okay. Oh! Tallcat has an excellent point. 2 not being a bomb is huge, because remember, the only way this could be 7 was for it to see 4 things in this box. And as Tristan pointed out, it doesn't have to be this 4, and 3 things up there. But it can't anymore, because that's not a bomb. Okay, beautiful. Beautiful, Tallcat. Okay, so that's a 1. So that actually places the 1 over here. Not in such a place as to tell us whether one is a bomb or not, but hey, beggars can't be choosers. Okay, so there's a 1 in one of those two cells. Okay, so this sees a total of 1 bombs. So if this is a 3, then that would mean that it looked like that. Exactly. If this is a 4, it would look like that. But in particular, no, all I know is at least 2 of these are bombs. It's the same as this. Oops. It's the same as this one over here. But at least 2 of these 3 are bombs. Okay, I'm hearing we can figure out which of these is a 3 and which of these is a 4, which seems like it would be very helpful. So only 1 of all of these cells is a bomb. Don't quite see it. 3 is a bomb. Yes, I agree. But box 4 is not. Yeah, so 1 of these 2 is a bomb. And 1 of these 2 is a bomb. And I think we could even do something fancy. Like, I think this one... Yeah, this one and this one are different. So cells like this and this can't be 3 and 4. So the other 3 and 4 in this box has to be up here somewhere or over here. There's 1 in there, so there's either 3 bombs there. Yeah. Okay. The most bombs this thing could possibly see is 7. So this is certainly from 3, 4, not 5, 6, 7. I think it's very unlikely that it's 7. But I'm not sure I can prove it. Okay, I'm hearing it can't see 7. That breaks the 1. Ah, yes. Okay, so it can't be 7. Perfect. Good catch, Tristan. So this is 3, 4, or 6. I would love to say this sees both 3, 4s, so it has to be a 6, because that would make my life much easier, but I do not think I can do that. Let's see. 9 in column 5 actually only has a couple places. I'm noting 9 can never go in circles, so I'm trying to. So I was just looking to see if there was anywhere where I could use that to do anything beneficial with 9s. Okay, so likewise says if row 3, column 1 is a 4, row 4, column 2 would would have to be a 3. Wait, if this is a 4, that's a 3. Why would this also have to be a 3? 3 is the only known bomb digit so far. What cells around the 1 in box 5 can be mines? Oh, can these be mines? Maybe these can't be mines. Ah, yeah, there's no way. That's a good point. That's a good point, 57. These can't be mines, because either this is a 3, in which case it is the bomb that one sees, or this is a 4, in which case I have to put a bomb in one of these two places. So I think these can't be mines. Feel free to jump in if that logic did not make sense and I did something horribly wrong, but I believe that. Why can't the 4 see the bottom 3 and the 1? I'm not sure which 4 we're talking about. Oh, sorry, I screwed this up. Okay, yes, completely right. So if this is a 4, yep, I was wrong. If this is a 4, that's fine. These can be the bombs and 1 can be the bomb. And then nothing is wrong. Actually, I think that might subtly break over here. Let's see. So what are the... So now this is a 3. It needs to see 3 bombs. It sees that one. And it would need to see 2 more. I guess it could see 2 more in there. Never mind. Okay. I agree. This being a 1, though, does mean that these aren't 1. That will be my profound observation of the day. It was a very good point. It completely got me. I believed it. Let's see. I'm trying to figure out a place we could use the negative constraint. Like this 2, not seeing 2 bombs, seems maybe relevant. What does it see? Does it see more than 2 or less than 2? Oh, Tallcat's going to tell us the answer. Excellent, excellent. There's a 2-8 pair in box 1. There is a 2-8 pair in box 1. Wow. 2-8 hidden pair. These are the only places that 2 and 8 can go, because there's a 2-8 in the row and a 2-8 in the column, and these things are not 2 and 8. That is amazing. Wow. Yeah, I don't know if it does anything, but it let me put some things in the grid, which is exciting, given that not a lot has gone in the grid in this puzzle. So the 2 is not a bomb. And so the 8 might be a bomb. If 8 is not a bomb, that's a bomb. Which is interesting. Let's see. Let's see. If this is 3, 4, it's that 3 or 4. Is that a problem? I don't think so. Which means it's that 3 or 4. Yeah, nothing I see. Hey, Virtual, welcome back. Yeah, 8 is very sus, as the youths say, these days. Row 4, column 3 can't be a 3. Yes, that is an excellent point, Nebu. If this was a 3, 3 is a bomb, this 4 would need to see all the bombs, and it wouldn't see it. Green is definitely not bomb, so you'll be happy to know we have actually identified. So we know the digit 3 is a bomb. We know the digit 2 is not a bomb. And we know these cells aren't bombs. And that is... that may be all we know. But knowing is half the battle or something. This being a 6 seems awfully hard. Yes, we know 4 is not a bomb. Sorry, we know 4 is not a bomb. Not saying it's impossible. I 100% believe it could happen. It just seems very hard. We get a digit here. I like digits. Yeah, I mean, the fact that this can be a 5 certainly makes 6 not seem completely ludicrous. If this wants to be a 6, where do the bombs go? Because I can only put one bomb in all of those spots. So one bomb, I can't put a bomb there. 2, 3, 4, 5. And I'm still not at 6. So yeah, this is just a 4. Perfect. Okay, so that's a 4, that's a 3, that's a 4, that's a 3. Oops. That's a 4, that's a 3. Okay, so now we need a color for is a bomb. We'll make is a bomb purple. I wish there was a more obnoxious color. Oh, except 4 is not a bomb. Because I feel like the bomb should be really ostentatious, but what are you going to do? So that 3 is a bomb. That 4 is not a bomb. And now everyone in chat is saying, so 8 is a bomb, which I've always been suspicious about that 8. Yeah, so this 4 means everything around it over here has to be a bomb. All of those are bombs, because it sees a 2, and 2 is not a bomb. So 7's a bomb. 8's a bomb. So 7's a bomb. 8's a bomb. So 8's are all bombs. Let's see. This 4 has to be forced, right? It sees 2 there. It can only see 1 there. Nope, not quite. Almost. Let's see. So how many bomb digits are there again? There's 4 total bomb digits, and we know one of them is 3, one of them is 7, one of them is 8. And so there's one more to find. And I'm told I missed an 8. I did miss an 8. Okay, and so now we hear 1 is not a bomb. So why is 1 not a bomb? The center 4 and 1 both see the 8. Yeah, so it is true. So that this is an excellent point that I do definitely believe. The 1 sees an 8 in one of these 4 cells, because these are the only places 8 can go. So these are not bombs. I don't know what they are, but they're not bombs. So one of these is a bomb. It's the logic I did earlier, but righter now. Because now I know 8 is a bomb, so I know that this actually sees an 8. And so I know this is sated. Uh, I also think 1 is sus. I would like to prove 1's guilt. Yeah, this just doesn't rule out 1 as a bomb, I don't think. Okay, there is 1 bomb over here. Trying to channel the previous puzzle and look for negative constraint applications. I don't see any yet, though. Let's see. There is a 4 over down here. Ah, yes. Good point, Tallcat. This cell is definitely not a bomb, because this 1 already sees the 8. Let's see. There's definitely a 4 in one of these 2 cells. As I try to get my chair to change positions. There we go. All right. The 7 is in column 1 in box 4. That's true. One of these 2 is a 7. So this is a 1-7 pair. So this isn't 1 or 7. Or 6 while I'm looking at it. That one's not 6 either. Making a lot of progress. This one's not 8. Let's see. Seven in row 6 in box 5. Ah, yes. Good point. The 8 is the only bomb that's up here other than possibly the 1. So the 7 is definitely down here. And so that rules 7 out of there. That was an excellent catch, Andrew. So that's a 7. Also 3. The same exact argument does apply to 3, yes. So there's a 3 down here. Now, it seems nigh impossible to make one of these a 7, but all the previous times I've said that and tried to prove it, it's gone badly. Let's see. So 3 is here, so 3 is up here now, somewhere. Let's see. 7 is in one of these 2 cells. This one's not a 5, I have deduced. In box 6. Ah, yeah, okay, so 7. Wait. Oh, yeah, the 3. Sorry, the 3. We put a 3 here. And when we put a 3 here, that 3 is next to the 1, and remember 3 is a bomb. So these are all not bombs. Those are all safe. And because they're safe, that's not a 7. Excellent, excellent. Yep. Thanks for getting me there, Tall Cat and Ranks, doing the teamwork. So we've placed, quote, the 7. When we say the 7, oh yeah, okay, so 7 here. That's the 7. Okay, so now we've got 2 bombs here. We've got 1 bomb here. And so 1 or 5 is a bomb. Right? So the last bomb is 1 or 5. But we don't know which one. But any digit that is not 3, 7, 1, 5, or 8, those are all not bombs. So 6 can't be a bomb, for example. Okay, so this 5 is getting at most 1 bomb here, 2 bombs there, maybe. 5, yeah. Let's see. So if one of these is a bomb, that's 1, 2, 3, 4. Okay, so no matter what, this has to be a bomb because the 5 needs to see 5 bombs. Likewise, gets this exactly right. So this cell here needs to be a bomb, and one of these 2 needs to be a bomb, and this needs to be a bomb. So this is the 3 and is a bomb. This is not a 3. That's something. It is a 1, 5. It's not a 5. But one of these 2 has to be a bomb, so the 8 is not over there. So this 8 is over here somewhere. Okay. Row 4, column 9 is green. Yes. That is now green. So we know where this gets its bomb from. Let's see. We know there's an 8 down here. I've heard placing of 2s. Oh, placing of 2s in box 6. So, yes. Perfect. That's a 2. Good catch. So is row 3, column 9. Okay, so people in chat are both... I have someone in chat proving that 1 is the bomb, and someone in chat proving that 5 is the bomb. So that's very exciting. But whichever it is, row 4 has its bombs. So these are not bombs. Which means that's the 8 and is a bomb. That's not a bomb, which I should have marked before because I said it out loud and never marked it. So this is not an 8. I intended to clear the 2s from row 5, but instead I added more. Good. Sounds like me. Yeah, one of these 2 is a bomb, but I don't know which. Let's see. So 4 in box 4 needs 2 more bombs. It can only have 2 more bombs, but it can have them. Those are bombs. So this is not a bomb because that was the last bomb for the row. This was the last bomb for the box. So 1 is not a bomb. Okay. Despite all the suspicion, 1 has been acquitted. So 1 is not the bomb, so it is 5 that is the bomb of those. Oops, I tried to make that purple. It didn't go. So let's see. Okay, so this isn't 8 anymore. It's not 9. It's not 6. It is 5. I'm glad you were a 1 is not the bomb truther the whole time. It's good that 1 had someone to stand up for its good name. So that works out like that. Row 3, column 7 must be a 3. So this one can't be a 3. Oh, yeah, because it's the only bomb left in the column. How about we make it black instead? There we go. Okay. All of those are green because the column is done for bombs. This is purple. This is green. Column 7 has all its bombs. Got that. Let's see. So, what's left in this row? 2, 3, 4, 5. We need a 6 and a 9. Worm's day of great joy is not over yet. So that's a 6 or a 9 as well. I don't think any of the circles in box 7 can be a 7. Let's see. This just does not see 7 possible cells. This does not see 7 possible cells. I agree. So that's a 7. That's a 9. 7 is a bomb. 9 is not a bomb. Oops. No, 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 not that. So these are both bombs by the box or row or whatever you want. So they are the other 2 bombs, which are 5 and 3. And I don't think I know the order yet. Let's see. Oh, but I bet I can find it, because this certainly isn't a 3. So that's a 5. That's a 3. It sees all 5 already, so that's not a bomb. This does not see all 3, so we don't know about that as of yet. This 5 still needs to see 2 more. I don't think I know exactly how that's going to work out yet. Let's see. This 1 has been proven innocent of all charges. Let's see. There's a 4 down here. Man, the bombs were 3, 4, 5, 7, and 8. 6 must have just gotten out of the life before things got bad for that crowd. Let's see. 2, 3, 4, 5, 6, 7, 8, 9. Let's see. So this is a 6 or a 9. These are 2, 3, 4, 6, 9. What one am I missing? 1, 2, 4. 4. The other one's a 4. I got there in the end. 3 in column 3 is in... 3 in column 3 is there and nowhere else. So that is purple. Good catch, Barbie. Let's see. So this is green. This is 5. Let's see. This is 6, 9. So many things to resolve. Yeah, everything's now sort of just collapsing all at once in a beautiful finale. Let's see. So, this one is green. I never gave it its due. Yes, this is a terrific puzzle, which definitely needs to be adapted into either a short story or a movie, uh, possibly both. 6, 9. Let's see. Okay, so that's not a 9. That's not a 5. That's not a 6. Let's see. The remaining bomb here is a 5, so this is not a bomb. Let's see. The remaining bomb in this column is a 3. Oh yes, the sequel to this where the bombs are going after. Every clue is correct unless it contains an odd number of 2s, 3s, 5s, and 7s. Or sorry, 3s, 5s, 7s, and 8s. Let's see. So one of these is a 4, but also one of them is a 3. So this is a 3-4 pair. This is not a 2 or a 5, so this is a 9, which I suspect chat will have been unhappy about. Now, when I said this is a 3-4 pair, what I actually typed was a 3-7 pair. And those are not the same thing. That 9 looks up there and sees a 6 and a 9 and a 6 and a 9. That's not a 9. That 6 sees that 9. These aren't 9, so that is 9. So these aren't 9. Let's see. I think I caught the pencil mark error before it caused complete disaster. Yeah, somehow my fingers going up and down on the number pad is something that I struggle with. I very often confuse a number with another number that is the same mod 3 because I move up or down or whatever. Okay. So we still need a 5 in this box. It's going to go in one of those two places. We still need a 7 in this box, and I don't actually know where it goes. Let's see. I've heard that I should reason about row 9, column 6. Okay, what could this possibly be? Well, I don't think it can possibly be anything other than a 1. So that was a good catch. And so that's a bomb. 1 is innocent. Let's see. Which bomb is it? It's either a 3 or a 7. Wow. We're really going to hit that one home. Let's see. So 1s. Okay, there's got to be a 2 in here somewhere. I don't know where. Well, you know, they're unconfirmed rumors when I first hear them, but then they eventually percolate through my brain, hopefully. That's not a 9, by the way. Let's see. 1 and 7. Don't know yet. Where is 1 in row 3? Exactly there, as it would happen. So then what's left in row 3? A 4. No, not a 4. A 6 and a 9. Okay, so that's a 6. That's a 9. That's a 4. That's a 6. All of these are purple. Because somehow in this column we had all the innocents filled in. So these are 3, 5, 7, and 8. That one's not 3 or 8. That one's not 5. That one's not 8. Let's see. There had to be exactly 2 bombs here. Oh, there's going to be no matter what. I was worried that I couldn't find anywhere to put a 3 in box 3, and then I realized I already had a 3 in box 3. Let's see. This should be very nearly wrapping up. let's see, there's got to be a 6 in this column somewhere because 6 is already there. So 6 is in one of these two places, which is not super exciting, if I'm honest. Let's see. Still no 8s in one of these places. Still no 3s in one of these places. Yes, there's nowhere to put my second 3 in box 3, which is very disappointing. Okay, what is left in this column? We have a 2 to place, a 3, a 6, a 7. I think that's it. Okay, so this is not a 3 or a 7. So that's a 2-6 pair, so that's not a 2-6 pair. What on earth did I hit? Okay, so these are not 2 or 6. They are 3 and 7. Uh-oh, what did I do? Nope, nope, nope. I did not do this right. Okay. Try 3. What's left in this column? 2, 3, 4, 6, 7. Yeah, I just missed a number somehow, apparently. But this one isn't 3 or 7 because it's an innocent. That one's not 2 or 3. That one's not 3 either. In fact, actually, 3 just is definitely here and has super been there for a long time, and I've just not been noticing it. Let's see. So that's not a 3. It's good to know. Let's see. This 5 needs one more, so it needs one more over there. So this is definitely a bomb, because this 5 still needs one more here, and the box needs 2 more bombs. So that's a 7, because it's the only bomb left that it could be. So that's not a 7. Let's see. 3, that's a 5. Okay. That's not a 6. That's not a 2. Oh, there was a 2 in the box. Who knew? Let's see. Okay, yeah, there's a 7 up here. And then a 2, 4, 6 left. Okay, this row, this must have not been cleaned up. Let's see, it's not a 6. Could still be a 1 or a 5 or a 7. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so this is... I have to admit, this is fighting more than I thought it would at this point. Let's see. So that's 4, 5, 6. That's not a 6. Also possible I am slow. Also possible both. Let's see. 8's definitely down there. 3 is definitely down there. Yeah, so this is the 8 that is going in here. Let's see, 8, 7, 3. So there's a 5 here. Well, get a time machine, and then you can go back and help me before then. See something, but it's tricky. Oh, no. See, there's 1 here. There's 1 here. Oh, I've got to be thinking about the negative constraint, don't I? That's the thing I'm not thinking about as I'm doing this. So... is there some negative constraint somewhere that thing, row 9, column 1, can't be a 5? Because of the negative constraint? Ah, yeah, okay, so exactly, yeah, okay, that is very tricky, but it's very cool. One of these is a bomb. If I make this 5, it's also a bomb, which means that this would then be a 2, which would see exactly 2 bombs. So it's not a 2, it's a 5. So That does that. That was tricky, but I had just completely forgotten about the existence of the negative constraint, I will admit, so I was not even looking for it. I did not color that right. Try to. Let's see. Oh, this is in a box with a given 6. One of row 2, column 6 and row 2, column 8 must be a bomb. Row 2, column 6 and row 2, column 8. Sorry. Row 2, column 6 and row 2, column 8. One of these, right. So that's a good point. So one of these has to be a bomb, or the 3 is right. So this is not a bomb. Okay, so one of these is a bomb. That is a very good spot. Okay. So one of these is a 1. I guess I am seeing. That's not the best, but let's see. Okay, what's up here going on? So this can't be 1 or 2 or 3. It could be 4. Can't be 5. Could be 6. No, it can't be 6. It can't be 7 or 8, and could be 9. In fact, actually, the 9 in this box has to be in one of these two cells. Let's see. Follow up on row 2, column 4, now that it's not a bomb. Okay, so if this is... Oh, it's not a 5 because it's not a bomb. Let's see. If it's a 4... that would be a 5. I was thinking this is going to give me some sort of like negative constraint violation, but sadly I don't think it does. Oh, but it does give me a 4, 6, 7 triple. So that's a 5. And is purple. Excellent. Okay, so... so 5 is... hooray! Okay, so there was a negative constraint over here that one of these had to be a bomb. Sadly, I don't think that immediately helps me. Okay. Oh, no, this sees 5 things, so it could be anything. This 2, though, this 2 would see 2 bombs if this was a 7. So it can't be a 7. So that's the last bomb in that row. That's green. So this is green. This is a bomb. So it's not a 1. It is a 5 or a 7. Okay, negative constraint on row 3, column 5. Oh, got there. Let's see. That one's fine. So these are either both bombs or neither of them are bombs. Do I know which? I don't think so. Oh, one is placed in box 3. That's a good thing to have. So one is in one of these two places. Row 2, column 6 deserves my loving attention. Oh, excellent. Yes, row 2, column 6. How on earth did Niverio make the negative constraint come up this many times? Okay, so 6, 4, 2, 6. 4. Did I mess up, or did I just say something out loud that wasn't true? Let's see. This is 8, 6, 5, 4, 3, 2. Okay, so I think these are a 2-8 pair. Let's see. Okay, so where is 4 in this column? Oh, that 4 looks over and sees a 3 and a 4. So that is purple. That is green. Okay, so that 3 looks back over here. That's not a 3. So that is a 3. Okay. I need another purple in this row, so that's a purple. So these are green. So this one's not a 5 or a 7. Or a 2. It's a 1 or a 9. Let's see. This is a 5 or a 7, but it's not a 7, so it's a 5. That's a 7. That's a 5. Oh, this 9C is a 1, 9. So that's a 1. 7, 1. 7 is guilty. 1 is innocent. This is just not a 1 anymore. So I need a 9 in this column somewhere. And what else do I need? A 9 and a 4. Okay, so yeah, so these are both 4, 9, except this 4 sees it, so that's a 9. So that's a 4, so that's a 9. Excellent. So what's left here? 2, 4, 6. All right, 2, 4, 6 are all the innocent digits that have not yet been placed in this box. That's not a 4, so that's a 2, 6 pair, so that's an 8. Guilty. Innocent. 2. Not a 2. Also sees the given 6. So it's a 4. And then we are left with a deadly pattern, which I assume is resolved by this cell. Hey, Jovi, how are you? Unfortunately, you came just as I'm finishing up, but this cell here is going to do the last deed of the puzzle, because this can't be a 2. So it's a 6. That's a 2. That's a 6. That's a 2. Oh, I'm not actually done. That's an 8. That's a 7. Now I'm actually done. Alrighty. Well, thanks for coming by, everyone. It's been a fun time. These were a bit more challenging than last time, I think. Yeah, this was a day of difficult for me puzzles. I feel like I kind of got drugged by chat through the first one there, where it seems that all 20 people in chat had already done the puzzle that I was doing, and so they pointed out things about 23 cages that I wish I could say I'm going to carry forward to my future solving, but I fear that's probably not going to be the case, and probably next week you're going to be telling me that you can't put a 7 in a 23 cage or something again. But thank you for coming, anyone. For everyone, thank you for all your help with the puzzles, as always. Chat did help me count to 9. That was incredibly bad. I had even looked at the cage multiple times and convinced myself that, man, I wish it had 9 digits in it, but it doesn't, even though it did. But have a wonderful night, and I'll see you all next week when I will be streaming again on Saturday at a similar time. And additionally, boy, my camera's in a really weird place. I had not looked at it in a while. But anyway, probably after next Saturday, I'll probably start streaming an extra day. I'll figure out when that will be, but after my finals are over, I will be happy to stream some more. Anyway, have a great night, everyone. Ta-ta for now.